As humanity prepares to establish self-sustaining agricultural systems on Mars, scientists face a crucial decision. Which energy source will power these farms? Solar energy or nuclear energy? On a planet with such a harsh environment, the chosen energy source must be stable, sustainable, and above all, safe. Solar and nuclear power are the leading candidates, each offering unique advantages and challenges. To determine the best solution, scientists must assess environmental factors, cost efficiency, and long-term sustainability. Solar energy seems like an obvious choice due to Mars's exposure to sunlight, unhindered by an ozone layer like on Earth. However, because Mars is farther from the sun, the amount of solar radiation reaching its surface is only about 40% of what Earth receives. This means solar panels on Mars need to cover larger areas to collect sufficient energy. Additionally, scientists must account for the frequent dust storms that block sunlight and reduce solar panel efficiency. Nuclear energy, on the other hand, provides a stable, reliable source of power, regardless of weather conditions. Compact nuclear reactors can generate continuous energy without reliance on sunlight or atmospheric conditions. However, the challenge lies in managing the safety and operational complexities of nuclear reactors on Mars. Any malfunction in a nuclear system could have catastrophic consequences, particularly in such a remote and hostile environment. Mars receives only 40% of the sunlight. Earth does due to its distance from the sun. This presents a significant challenge for solar power. Moreover, Mars experiences extreme weather conditions, including frequent dust storms that can last for days or even months, sometimes enveloping the entire planet. These storms drastically reduce the amount of sunlight that reaches the surface, often plunging sunlight levels close to zero. Additionally, strong Martian winds can damage solar panels over time by eroding their surfaces. Given these challenges, relying solely on solar energy for Mars agriculture poses a risk. The ideal solution may involve a hybrid system combining solar and nuclear energy, providing backup power when solar panels cannot operate efficiently due to reduced sunlight. Martian dust storms are a major obstacle to using solar energy. These storms not only reduce sunlight, but also coat solar panels with fine dust, significantly lowering their efficiency. To address this, scientists are exploring technologies like self-cleaning robots or anti-dust coatings for solar panels. These panels could be equipped with special coatings to prevent dust from sticking or fitted with vibration systems that shake off accumulated dust. Another solution could be the use of foldable solar panels that retract during dust storms, protecting them from damage and minimizing dust buildup. These innovations aim to ensure the solar panels operate at maximum efficiency despite the unpredictable Martian weather. Building solar farms on Mars requires careful planning to balance cost efficiency with energy output. To save costs, the solar fields could use lightweight materials that are easy to transport, but durable enough to withstand Martian winds and dust storms. The solar panels would be deployed in modular units that can be quickly assembled by autonomous robots. These panels would also use automated sun tracking systems to maximize energy collection throughout the Martian day, adjusting their angles to capture the optimal amount of sunlight. AI, artificial intelligence, will play a vital role in ensuring the solar power systems on Mars operate at peak efficiency. AI can continuously monitor sunlight conditions, dust levels, and other environmental factors to adjust the tilt and angle of the solar panels in real time, ensuring they capture the most energy possible. AI systems will also predict dust storms and adjust the panels accordingly. either cleaning them or retracting them to prevent damage. When solar power production drops during long storms, AI will switch to backup energy reserves from stored power cells or nuclear energy sources, ensuring continuous power supply. Storing energy on Mars is a critical challenge, particularly during long dust storms when solar energy is unavailable. Scientists are developing high-capacity batteries using lithium-ion or solid-state technology to store large amounts of energy. These cells must be durable enough to operate in extreme Martian conditions and capable of storing enough power to support agriculture for extended periods. The energy storage system will be connected to the AI, which will regulate energy usage and distribution, ensuring that enough power is stored for critical operations during times of low sunlight, such as during extended dust storms. Nuclear energy offers a reliable solution, especially given the unpredictability of solar power on Mars. Systems like NASA's kilo-power small-scale nuclear reactors are capable of generating steady energy without being affected by sunlight or storms. This makes nuclear power an attractive option for a consistent power supply. However, the risks of using nuclear energy are considerable. Any reactor malfunction could have devastating consequences in Mars's isolated environment. To mitigate these risks, nuclear reactors will be housed in underground bunkers with thick protective barriers, shielding the Martian environment from radiation. These reactors will be equipped with remote AI monitoring systems to detect any anomalies and automatically shut down in case of malfunction, ensuring the safety of nearby agricultural facilities. A combination of solar farms and nuclear power plants is expected to produce between 10 and 20 megawatts of energy, sufficient to power extensive greenhouse facilities. This energy output will be enough to sustain multiple greenhouses and farming infrastructures, supporting food production for an estimated 1,000 to 2,000 people. The agricultural output from these facilities will be critical for long-term human settlement on Mars, providing fresh crops and ensuring oxygen generation through plant growth, both necessary for the sustainability of Martian colonies. The energy systems on Mars will be divided into two main infrastructures: solar power stations and nuclear power plants. Each will consist of modules dedicated to specific functions. Energy harvesting. Module: solar panels or nuclear reactors that generate energy. Energy storage module: high-capacity battery cells to store energy for use during low production periods. Control and monitoring module: AI systems that oversee energy generation, distribution, and storage, safety and protection. Module: in the case of nuclear systems, this module will include radiation shielding and safety mechanisms to ensure stable reactor operation. Compared to Earth's power stations, the Martian energy infrastructure will rely more heavily on automation and AI to reduce the need for human maintenance. The modular design will also allow for quick assembly and easy scalability as the colony grows. The primary difference between Mars's energy infrastructure and Earth's lies in the extreme reliance on automation and the necessity for self-sufficient systems. Mars' energy infrastructure must operate with minimal human intervention due to the planet's remoteness and harsh conditions. This means integrating AI technology into every aspect of energy management, from optimizing solar panel angles to safely managing nuclear reactors. Additionally, environmental factors like dust storms and lower sunlight levels present challenges unique to Mars, requiring advanced solutions like self-cleaning solar panels, foldable systems, and underground nuclear reactors that are not typically needed on Earth.